Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, Chapter 1, Section 1, problem number 51. For 51, it says, find the expression for the function of the given curve, and the expression that they want is for the line segment joining the points 1, minus 3 and 5, 7. So in order to do this, we're going to have to think back to some of the stuff that we did in Algebra 1 with point-slope form and slope-intercept form. So with point-slope form, it takes the form of, here, I'll write this out. All right, point-slope form. And the reason it's called point-slope form is because it has 2 points and 1 slope. That's part of the formula. And what you usually use it for is to try to find the slope. So in this case, we're given 2 points, 1, minus 3 and 5, 7. And point slope form follows pretty much like this. You have y2 minus y1 equals m, where m is your slope, right? So I'll write slope. M times x2 minus x1. Okay, and here with these points that we have 1 minus 3 and we have 5, 7. Well, it doesn't matter which order you do this in. You just have to be very consistent with it. So to make things simple, let's have 1 minus 3 be our first coordinate. So we'll have 1 as x1 and minus 3 as y1. We'll label 5 as x2 and 7 as y2. So here we go. We'll have y2 minus y1. That would be 7 minus a minus 3. And that's going to be equal to m, our slope, times x2, which is 5, minus x1 is 1. There we go. So the 7 minus 3, that ends up being 7 plus 3, so we get 10 equals m times 4. So we'll just rewrite that to clean it up a little bit. 10 equals 4m. And then if we divide both sides by 4, then we find that m is equal to 10 over 4. And when we simplify that slope, we end up getting our final answer that m equals 5 halves. Now, we're not entirely done with the problem yet because we still need to find our equation for the formula and then graph it. Well, actually, no, we don't have to graph it. We just have to find the expression for the function. So that's nice, actually. Here that we have 5 halves for our slope, let's take another point at random, right? So let's take, just for positive numbers, let's take this 5, 7 here. So now we're going to use what's called slope-intercept form. And slope-intercept form is kind of the standard y equals mx plus b that we see frequently with any sort of linear equations, right? So y, which is your function, equals m, the slope, times x, that's your input, plus b. So again, I'll write here where m is your slope, b is your y-intercept. B is whatever your function equals when x equals 0. So that's part of the reason why it's called slope-intercept form, is we have a slope m and we have an intercept b. So let's go ahead and we want to achieve that general form. So that's our end goal, y equals mx plus b. Let's go back to point-slope form for a second. And let's input, 5, 7. Let's go ahead and have y2, some arbitrary y2, minus 7, because that's our y1, y2 minus 7 equals m, our slope. That is 5 halves times some arbitrary x minus, well, our x1 is 5, because our point is 5 comma 7. So x minus 5. And this is what I was talking about why it's important that we're consistent with whatever we label our points as, is because we couldn't have 7 be our x1 and 5 be our, 7 can't be y1 and then 5 can't just be x2, right? Whatever's a 1 and a 1 has to stay with 1 and 1. Whatever's x2, y2, you need to keep the coordinate pairs with each other. Otherwise, the equation doesn't work. So anyways, let's go ahead and do some algebra with this. And we'll distribute this 5 halves in. So now we have y minus 7 equals 5 halves x minus, this is going to be a 25 over 2. Okay, now let's go ahead and I'll switch back to gray now. So we'll add 7 on both sides. We get y equals 5 halves x minus 25 over 2 plus 7. Now, I do want to make it so that I can add these numbers together. So let's go ahead and multiply 7 by 2 over 2. And that will give us y equals 5 halves x minus 25 over 2 plus 14 over 2. So negative 25 plus 14. That's going to give us a minus 11 over 2. And so our final function for this is going to be y equals 5 halves x minus 11 over 2. And this is for the range that they're asking. This is for -1 all the way up to positive 5. So that's everything for this problem. It's kind of a longer problem, right? But we did make it, and we were able to make it using point-slope form, and we were able to achieve slope-intercept form in the end. So thank you, and if you have any questions, definitely feel free to ask, and I'll get back as soon as I can. So thank you.